Alright, welcome back for Explain 1 of 18.1, where we will be graphing sine functions and cosine functions. So it says, for each of these functions, identify a vertical stretch or compression, and of course a horizontal stretch or compression, and then graph those functions. So we got a graph, hence the graph, and identify something called the period. Okay? So, first things first, we're given here y equals 3 sine 2x. Okay, just so you know, our a value is going to be 3. Now 2 is in the same place as 1 over b. So we're going to need to kind of set up an equation and solve that out. I know, your favorite, right? So here a is going to be 3. Since it looks like 1 over b is equal to 2, we're going to solve for b. How do we do that? Right? It's like, what do I do? Well, let's put that over 1. Let's cross multiply. What's 1 times 1? 1. Not too bad. 2 times b? 2b. And what's the opposite of multiplying by 2? How would I get rid of that multiplying by 2? 2, right? Let's go ahead and divide, and that should be b equals about 1/2. Okay, now we're going to find period, just so you know. Period is essentially, from your textbook, it's the length of time, or the length that you see for that value than we were seeing the waves, right? For it to come back to its starting position. So if it started kind of here, the period, oh, I didn't mean to go that far, but the period would be kind of the length from here to here for it to come back to its starting position. Okay, just so you know. Yeah. Alright, so it wants us to find the period of the function. Just so you know, period of the function can be found by multiplying 2 pi times our b value, which in this case is 1/2. Now notice I have absolute value bars. What's the absolute value of pi? Or I'm sorry, absolute value of 1/2? Well, that would just be 1/2. And we could use a calculator, but I believe in you guys. You can do this. 2 pi times 1 would be 2 pi. 1 times 2 would be 2. And 2 divided by 2 would be what? 1, right? So the period that it takes would be about pi. Okay, and that's a length of measurement. In fact, you can kind of see, like if I start here and go to here, that would be my period, that it would kind of go up and then back down. Okay, before we actually graph this out, yes, I'll show you the Desmos graphing calculator so that way we can kind of plot this out, but still, let's kind of identify the vertical and horizontal stretch. So let's say it says, so the graph of the parent sine function must be a vertical stretch or compression. So our a value is 3. Our b value is 1/2. If it's a whole number, will it be stretched or compressed? Stretched. And you can keep this as a reference so you kind of know. And if our b value is a fraction, will it be stretched or compressed? Compressed. And all that means is just essentially this would probably be a little bit longer, and it'll probably go through a lot more waves. So this means it's going to be a little bit longer than, say, something shorter. And this compression just means that I'm going to go probably through a lot more waves in a short amount of time than if I just kind of took in the same amount of time I would have just taken one turn. Okay, so let's go ahead and use our Desmos graphing calculator to kind of graph this out and find some values. Okay, so alright, so I opened up Desmos.com and I saw we're going to start graphing. It's going to load, and we're going to type in our equation, y equals 3. I need the sine function. So function we're going to use for trig. Oh, how convenient. Sine 2 x. Okay. Oh, and there is my points, which is kind of nice. In fact, I really like that without even doing a table, guys. Look at this. Without even doing a table, it's already giving me values that I need, so I can plot my points on my graph here. What graph? This graph. So take some time if you want to record these points. Also, you can do this for your homework or anything like that, but we're going to graph some of these points here in just a second. Alright, so the first point we got was 0, 0. I always like to start with the simple stuff, 0, 0. The next point we got was, actually there was a pi here, pi 0. Oh, pi 0. And that means that it went up at some point here. Pretty much at every half point. So I got 0, 0. Oh, sorry, that should be there. 0, 0. I also got half, or pi over 2, 0. And I also got pi, 0. And I noticed here that it went up to about 1, 2, 3. About the halfway point between these two. It went up and then down. And then it also went down to about -1, -2, -3. About halfway there. Up and then back, or down and back up. It then continued that pattern for a couple more times, actually. And it also went backwards too. So that was negative pi over 2, 0. And it kind of went down halfway through that to -3. You'll notice that there's a pattern here. It kind of keeps doing the same thing over and over again for a lot of these. In fact, it goes up to 3 and back down, and it goes down to -3 and back up, and it goes here. I'm going to kind of put points here so you can kind of see where they kind of come back down to the midline, the middle line. Oh, that kind of makes sense. Midline, middle line, right? Goes up to 3 and back down, down to 3 and back up to 3 and back down. So just so you know, that 3 value and that 3 value on the negative side, that kind of goes with the A value here. So that kind of gives you another word that we're going to use, our amplitude, which is pretty much how tall or how low our graph goes. A period is just how long it takes to go from our starting point. So you notice here it starts, goes up and down, and then back up. So it kind of completes a whole wave from this end to this end. And I'll go ahead and highlight that so you can kind of see that not only did we compute the right response, but this is our period as according to what we calculated. Okay. Alright, so just keep that in mind. Some stuff I want you to just kind of look at, not just graph it and move on, but also some stuff to just notice. Part B, we're going to do cosine. So I'm going to change back to our pointer. And let's go ahead and see what our A value is going to be, which is about -3. That's going to be our amplitude. This is probably going to be just as high or just as low as the last one. And notice how this one is actually a fraction. Yay! In fact, if you want to kind of be obvious and say 1x, our 1 over b value, 1 divided by b, is actually equivalent to 1 over 2. And we're still going to solve out for b because we do want to find out our period, but at least we know that much. So that would be 1 over b equals 1/2. So let's cross multiply. What's 1 times b? B, right? And 1 times 2? 2. So here let's find our period of how long it's going to take to go from our starting point and back around. So that would be our period. We're going to find that out right now. So that would be 2 pi times 2 absolute value of 2. What's the absolute value of 2 anyways? 2, right? And what's 2 pi times 2? 4 pi. So our period value is actually going to kind of be a little bit longer. It's going to go from here to about there. So I'm going to highlight that in yellow so we can see if our prediction's correct or not. So it's going to take about this much time for it to kind of finish a wave. Alright, now let's go ahead and fill in these sentence starters first before we go and use Desmos. So it says, so the graph of the parent not sine cosine function, so fix that please, must be vertically blank, stretched or compressed. Well, our a value was -3, still a whole number, well, not a decimal, not a fraction, so still going to be stretched, like cheese. Which has nothing to do with this. Let's move on. Horizontally stretched or compressed by a factor of our b value is actually 2, which is a whole number. So it'll be horizontally stretched as well. Alright, with that being said, let's go ahead and go on to our Desmos. Instead of scientific, we're going to use our graphing calculator. And we are going to calculate some points and values so we can record this on our worksheet here. Oh, and notice one thing also here, that because the a value is negative, because it's -3, the graph will be reflected across the x or y axis. So keep that in mind. We're going to come back to it and see what it will be, okay, once we have a picture. Alright, so just like it says here, we're going to go to our Desmos calculator. We're going to write y equals, oh, not y minus, y equals -3 cosine. Where are you? Cosine is under trig functions, under functions. Cosine. Let's go ahead and write the next part, which is x divided by, I like that it gave a fraction, that's nice, over 2. We're going to close the parentheses. And I'm going to look at my graph here. I'm going to maximize it so I can really see it. Hide the keyboard because we really want to see this. So we get 0, -3. So you notice that cosine usually starts on the top and works its way down. Here it starts on the bottom. So I'm guessing it kind of reflected if I wrote my parent function, hopefully in a different color. And notice if I don't want to use the keyboard, I could just type in cosine. Notice how it's a reflection over this axis here, which is, I believe, our x-axis. So keep that in mind. But I'm more concerned with some of our points that are listed here, like 0, -3.5, pi over 0, 2 pi thirds. Oh, so when I move it, I have to re-put some of the points. But take some time, record these on a piece of paper, because we are going to transfer all of these values onto our paper so we can finish out part B. Okay? Alright, so let's record some of the values we saw on the last screen. That would be -pi0. It went as low as 0, -3, pi 0 again. It is half, or I said 2 pi 3, and 3 pi 0, and -2 pi 3. So it goes down and then up and then down. And I believe I had a 4 pi 3. So it does take a full 4 pi's to kind of go from starting position. Starts low, goes up, comes back down, ends in a low position again. It's kind of like a little anthill. Anyways, but at least I have my graph, and you can kind of fill out the rest if you'd like. In fact, I believe this is going to be 3 pi, and yes, I'm going to be going over into my words, but it doesn't matter because we want to have a full picture. And it'll come right back up again. Alright, so, but that's our graph. Much like it says on your worksheets and now on my screen, stop here and do the problem in your packet. Okay? We'll come back with Explain 2 on the next video. Okay? See you soon.